Morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
गुड मॉर्निंग हाँ माने
Good
के काहा
morning.
को कहूची माने एटा जणा पड़ने तो सेति
Sir, namaskar. Good morning, everyone. Respected Speaker Professor Jawan Meher, respected Principal Sri Ravindra Kumar Devta, respected Head of the Department Mathematics Sri Narsingu Panikai, all the participants. I, Dr. Mita Sharma, lecturer in mathematics, welcome you all to PANDIT Laxminarayan MISHRA lecture series conducted by Laxminarayan College, Jharsuguda. This is the 11th series of the series. First of all, I would like to request our respected principal, Sri Ravindra Kumar Devta, sir, to inaugurate the talk.
So, good morning, everybody. Good morning, Professor Meher.
गुड मॉर्निंग
HOD Mathematics, other faculty members of Department of Mathematics, IDP in charge, Dr. Purohit Madam, all the participants, I welcome you all to this webinar. As you all know, our college is conducting a webinar in the name of our founding father of this college, Dr. Laxminarayan MISHRA lecture series, and this is the 11th episode, and it is organized by Department of Mathematics. I congratulate you, I greet you, I wish you a bright, prosperous, happy new year. And I am a student of humanities, so I have least knowledge on mathematics, but you people are voracious, you people are knowledgeable, and I hope all the participants must give a true and rapt attention to the honorable, to the distinguished research person, Mr. Meher, Dr. Meher, and we let us start the webinar and listen to him. Thank you all.
Thank you very much, sir. Now I would like to invite our convener and head of the department, Sri Narsingu Panikai, to say few lines and introduce our speaker to the participants.
Now, I welcome to this 11 Pandit Laxminarayan MISHRA series. Now, I am going to introduce Professor Jawan Meher. Respected Principal Sir, respected Professor Jawan Meher, and all the participants. Now, I am going to introduce Professor Jawan Meher has completed his degree from JM College Sambalpur and master's from Utkal University, and he has completed his PhD from HRI Allahabad on the year 2012. After that, he has completed his postdoctoral from Queen's University, Canada. Then he has joined as an Inspire faculty at HSC Bangalore on 2013 and remains there till 2015. After that, he has joined as assistant professor in Niger, Bhubaneswar, and is continuing there till date. He has more than 22 publications in different journals. He has guided 1 postdoctoral, 1 PhD, and 2 MSc theses till date. And now, 1 PhD is continuing in his guidance. He has also visited many national and international institutions for workshops, conferences, and other talks. Today, we are fortunate to get an opportunity to learn from him through this webinar lecture. He is going to tell us on the topic Euler phi function or phi functions. This talk will be beneficial both for the students and teachers. Now, without any further delay, I will request Sir to start the talk.
So thank you very much for the introduction. And everybody is able to hear me? I feel so. So sound is not a problem. Subha Jauji?
हाँ सर
Oh, ठीक ଅଛି ମୁଁ ଏଇଟା କନେକ୍ଟ କରିଛି ସ୍କ୍ରିନରେ ଆସୁଛି ନା ନାହିଁ ଦେଖିବା ଦେଖାଯାଉଛି?
Yes, sir, it is visible.
Okay, so let me begin. So again, I thank the organizers and the Allen College staff. So who thought that I am I should give a talk. So thank you very much. And so we'll see. On this kind of talk, I'm giving for the first time on this writing pad. So let us see if any problem happens. Then we'll see. But we'll start. Let us see. If I don't think any problem will happen. But let us. So should we switch off the video? Otherwise, there will be a problem maybe. So let me switch off the video. Okay, so the title which I have written is Euler. So let me choose different. Euler phi function. So can you see whatever I have written on the screen? Like screen is visible?
Yes, sir.
Okay, thank you. So this is very basic. Like generally you have a course in number theory. Generally you study. I'll go from the beginning. So this, let me write this Euler phi function. So what is Euler phi function? I'll define and then I'll see some of this application and then what are the things involved and then what we need to do. That I'll be doing in this lecture. So what is Euler phi function? So this is a function from n to n. So n is the set of natural numbers. Set of natural numbers. Okay, what is defined by? What is this? So phi n is the number of integers between 1 and n and relatively prime to n. So relatively prime to n means like if you have seen this, relatively prime means that the GCD is 1. So GCD is 1. So that means I am collecting all those integers from 1 to n, which if I take GCD with n, so that is 1. So GCD means greatest common divisor. So that possibly everybody knows. So GCD is 1. So relatively prime means GCD is 1. So what is this? So this is, I am counting the number. How many are there? How many numbers are there from 1 to n, which are relatively prime to n, and how many integers are there which are relatively prime to n, between 1 and n. That is phi of n. So let us see for some example what is phi of 2. So the number phi of 2, I am saying that this is 1, because what are numbers between 1 and 2 is, I have two numbers, but 2 is not relatively prime to 2, because the GCD is 2. 2 GCD is 2. So 1 is GCD 1 with 2. So that is why phi 2 is 1. So similarly, one can compute that easily, that this is 2, because I have 1, 2, 3, only 3 each, with GCD 3 is 3, and then 1 GCD 3 1 GCD is 1, 3 2 GCD is also 1. So, and for example, phi 4 if I compute, so we have 1 2 3 4, but GCD of 4 with 4 is 4, so we don't count that. GCD of 2 with 4 is 2, not 1. So I have two numbers. So this is some example, and you can see that how we calculate the number. It's just you look at, and then if GCD is 1, then you count that. And also you note that if P is a prime, if P, if P is a prime, P is a prime number, then phi of P is P minus 1. Okay, so that one can easily see, because that is the definition of the prime number. Prime number means if you take any number less than equal to P, then that is relatively prime with P except for P. Okay, so because you are counting number from 1 to n, so I am counting 1 up to P. P is not relatively prime to P, and the remaining will be relatively prime to P. So that is why this number is P minus 1. Okay, so let us state some important theorem, which is known as Euler theorem. So Euler theorem says that if n is a positive integer and GCD means greatest common divisor of A and n is 1, then we have phi, let me edit it. Then if, let me, oh sorry. Okay, so then we have, so this is nothing. So A power phi n is congruent to 1 mod n. Okay, so this will see that by some application of this result, but I am not going to prove this result. So this proof, just I write one line, that use group theory. Group theory, using group theory, one can prove that this is true. Okay, and GCD of 1 and n is 1. So this generally will write, this is the notation. This is GCD is 1 actually. So this bracket which I have put means like that. This is the GCD of A and N. That is the meaning. Okay, so what? So let me again explain something. So GCD, this is the notation. Proof, I am not going to write the proof, but what does this mean? The meaning of this is, everybody knows that a power I n minus 1 is divisible by n. So this is the meaning of this. So this is called a power phi n, is congruent to 1 mod n. So this is, and the meaning of this is this, that this is divisible by n, or n divides this. Okay, so and what does this mean? This means like if you divide a power phi n by n, then you get the remainder 1. So that is the meaning. Okay, so this is one thing, and then as a corollary, very simple corollary, this is called the Fermat's little theorem sometimes. It says that if P is a prime and P does not divide A, then A power P minus 1 is congruent to 1 mod P. So this actually follows directly from here, because we know that if P is a prime, phi P is P minus 1. Okay, phi P is P minus 1. So using, so proof is just using this. So phi P, so using Euler's theorem, we get this result. So here, like if you see the difference, here I am written that the GCD of A and N is 1. If I use it, P does not divide A, and P is a prime. So that means the GCD of A and P is 1. So that is why I can directly use Euler theorem, and then phi P is P minus 1 to get this result. Okay, so let us see some application. So one application which is very elementary application, and then people use, even high school standard people also sometimes use. I have seen in Olympiad students like solving this kind of problem. So the question is, what are the last 2 digits in the decimal representation of 3 power 41? Okay, so this like it is difficult to like calculate what will be 3 power 41, etc. Okay, but what it says, so how to find out the last 2 digits of decimal representation of 3 power 41? If you look at, like generally, suppose a simple number is given. Suppose I ask like that, this question will come. Okay, so this question will come. So what it says is that this question, I'll come to this. Let us do for a simple question. So what is the last 2 digits of, suppose I write this number, let me not write here, 1 2 5 6. So you can easily say that the last 2 digits is 56. Okay, 5 and 6. Okay, answer is, okay, answer is 56. How we get this? If you look at, if you divide by 100 this number, then you get remainder 56. Okay, dividing by 100, we get the remainder 56. Okay, and that is what we do. So like when you, okay, so we divide by 100 and we get whatever the two number, like the 2-digit number, which will be the remainder. That 2-digit number, that 2 digits will be the last 2 digits in the decimal expansion. That is how we look at. But this is very simple. Here you can find out the decimal expansion already given in the decimal expansion 1256. But 3 power 41. 3 power 41 means, like as I said, that it is very, like you have to spend a lot of time to calculate. But like using the Euler theorem, which I have written above, we can easily find out. So what it says, dividing by 100, we get remainder 56. And then what I have said here, that a power phi n, you divide by n, you get remainder 1. So a power phi n, if you divide by n, get remainder 1. Okay, so similar kind of thing. So in that form, what you write is that, okay, you write 3 power 41, you just look at what is x mod 100. Okay, so if we find x, then we are done. Okay, this is the same thing. Like what we are doing, divide by 100, what is the remainder, and then whatever these two numbers, that is what we get. Okay, so the question is, now look at, if we want to apply the Euler's theorem, then we first should have 3 is relatively prime to 100. This is true. Okay, so this is true. So then what I get, if I use that, 3 5 of 100 is congruent to 1 modulo 100. Okay, so then the question is how to find out phi of 100. So you cannot again be doing like 1, you take 100 and then look at which will be, that you can do, but that will take time, and maybe some problem will happen, like while calculation also, some error you may have while doing so. So what we do, like I'll come to this how to calculate. Just you take here, just you like I am saying that phi of 100 is 40. So I'll prove this actually, that how you get this. I'll come to this. So another important thing is that means you need to know how to compute the Euler function of a given number. So that will have simple formula. We'll come to that. So if I use that, now let us using this, we try to look at what are those 2 digits. So it says that 3 power 40 is congruent to 1 mod 100. Okay, but it says that 3 power 41. So what I do, if I multiply both sides 3, so 3 into 3 power 40 is congruent to 3 mod 100. Actually, you multiply and then you get the same thing. So this implies this is 3 power 41. So this implies 3 power 41 is congruent to 3 mod 100. So what are 2 digits? Because only 1 digit I am getting, so other digit is 0. That means, so that means the last 2 digits, are 0, 3. Okay, 0 and 3. Okay, I should write 0 and 3. Okay, so this is how we get. So the question is, like how I found out this thing. That means it is very, to use this, actually you need to know actually what is Euler phi function of a given number. So that you need to know, and then that you need a simple kind of formula, so that you should be able to easily find out. Okay, so let us do step by step. So we want a formula for, so because we saw that in application we use that, so we want a formula for phi of n. Okay, so let us go step by step. As I said, that we have seen that phi of p is p minus 1 if p is a prime number. Okay. Okay, so if p is a prime number, then we know this. So now let us see what is, if I evaluate phi function for p power r. So p power r is what? If p is a prime, and of course means like p r equal to 1 I have taken, I know. So let me write, this is not, r is bigger than equal to 2, positive integer. Okay, this is integer, bigger than equal to 2 and integer. So that means what I am trying to do is that first prime I know. So let us try to find out phi of p power r. That means prime power. So then I'll try to look at what will be Euler phi function of general integer, general positive integer. That we'll see. So what is this? So how to compute this? So by the definition, we know that phi p power r is the number of integers between 1 and p power r and relatively prime to p power r. Okay, so that means if I want to compute phi of p power r, so what we do, total number is p power r, 1 to p power r, and minus what I do, I have written the number of integers between 1 and pr and relatively prime to pr. So I subtract number of integer between 1 and pr and not relatively prime to p power r. So minus the number of integers between 1 and p power r and not relatively prime to p power r. So since so that means now let us look at this. Okay, then if I know this number, then I can subtract and then I can get this phi of p power r. So the question is, so let us list them. So that means list them first. Can we list them? List them means I'm trying to list all the integers between 1 and p power r and which are not relatively prime to p power r. So what is list them means like, so then the question is which numbers are between 1 to p power r and they have they are not relatively prime to p power r, means they have a their GCD is not equal to 1. If I take the GCD of that number with p power r, that is not equal to 1. But note that p power r, so only prime appearing here is p, means like p power r is there, but only prime which divides p power r is p. Okay, so then if I look at so those numbers which are not relatively prime to p power r will be multiple of p. So if I list them, I'm saying, okay, I just say that 1p, 2 into p, 3 into p, like that. If I go up to p power r minus 1 into p, okay, I'm saying that these are the integers between 1 and p power r and not relatively prime to p power r. Okay, so like one can easily see, because any number which is not relatively prime to p power r has to be a multiple of p, and I am taking all the multiples of p from 1 to p power r. That is means like I started from 1 into p, 2 into p, up to I can go up to p power r minus 1 into p. Okay, so no other integer which is between 1 to p power r and which is not in this list and which is not relatively prime to p power r. That one can see, because I have listed down all this number which are not relatively prime to p power r. So if you look at how many are there, if I have started from 1 and then I have gone up to p power r minus 1. So that means I have this number of the cardinality of this set is p power r minus 1. So that means this number is p power r minus 1. So thus we have phi of p power r is p power r minus p power r minus 1. Okay, so this is what? So prime power, if a number is a prime power, then I get this, that phi of p power r is p power r minus p power r minus 1. Next, the question is what is 5n? Okay, can we get a formula for general n? Because we have seen first for prime, then prime power, general integer n, okay, bigger than any integer. So to do this, actually we need some other things. So first result which I am going to prove is the following, that summation. So I'll explain what does this mean. Phi d dividing n is n. Okay, so this is the summation. So what is this summation? So this meaning of this summation is summation is over all positive divisors of n. Okay, so that means this summation is going over all positive. This is the notation when I write summation d dividing n. So this is the meaning of d dividing n. Okay, so this is the meaning. So this is the notation for this d, that slash means like standing line if I put, so that meaning is d divides n. And so that the summation, when I write, that summation is over all positive divisors of n. Okay, so I look at all the positive divisor, like for each positive divisor d, I get phi d. Another one again, like I take summation for each positive divisor, and then this says that if I take this summation, so this is n. So for example, like I'll come to the proof, but let us take n equal to oh sorry, what did happen? Look, oh sorry, something is a problem. So this is what. So now now consider n equal to 4. N equal to 4, then what are the positive divisors of 4? Then d, possibilities for d are like 1, 2 and 4. Okay, these are all the divisors of 4. So that means from here what I should take, if I apply this, phi 1 plus phi 2 plus phi 4 should be equal to 4. And you can see that we have seen that phi 1 like will be 1, because 1 is relatively prime to 1, because the city of 1 and 1 is 1. So this side, if I calculate, what I get, 1 plus phi 2 is 1. We have seen phi 4 is 2. we have calculated. So these are, so that means I am getting what I want, means like 1 plus 1 plus 2 is 4. So let us try to prove this result. So let us try to prove this result. So what I do to prove this result, so consider the n rational number So everything is mean like there is no problem with sound, no? Everybody is able to hear? Hello?
Yes, sir.
Oh,
Yes,
everything is fine. So this is visible also?
Yes, sir.
So any question anybody has so far? I can answer. Otherwise, I can proceed. Okay. Any question?
Sir, 5 of 100 equal to 40. How?
I didn't get the question. You are asking how that is 5 of 100 is 40?
Yes, sir.
That I said that I'll come to that. Means when I said that if I get a general formula for phi of n, then it will be automatically clear that how phi of 100 is 40. So that will be at the end actually. So, okay, then I feel that there is no other question. So let us consider n rational number. So I'm trying to prove this result that summation d dividing n phi d is n. So how I prove this? So you consider n rational number, which are n rational number, you consider 1 by n, 2 by n, 3 by n, up to n minus 1 by n and n by n. So n by n is 1 by 1 that you can say, or 1 that you say. So here you can see that all are distinct. Any question? Okay. So we have these are n in number. These are n in number because all are distinct. You can see that because I have 1 by n, 2 by n, 3 by n, all are distinct rational number. So all are n in number. So one, you can check that all are distinct. Distinct numbers. So distinct numbers means their total number is n. Because 1 to n I have done. And then all are less than or equal to 1. So that is the question. I mean, like only this one is 1 actually. This is 1. This will give you 1 n by n. Otherwise, the remaining thing will be less than 1. Strictly less than 1. If you choose, yes, of course, this n by n is 1. Otherwise, this other will be less than 1. Strictly less than 1. So what I do, reduce each to the lowest term. Okay, so lowest term means what? Possibly you know, for example, 1 by n, 2 by n, 3 by n, mean like maybe there is some cancellation, from the denominator and the numerator. So that you do it. That means, for example, 2 by 4. Okay. 2 by 4 if I write, 2 by 4 I can reduce it 1 by 2. So this is lowest term means if you have cancellation, you do that and then write it. If 2 by 4 appearing here, then just I write it 1 by 2 instead of writing 2 by 4. Okay, so this is the meaning that reduce each to the lowest term. So still we get the same number we get, but what we have now is let us count. Mean like this is, if you look at this is n numbers. I mean like n distinct rational numbers we have. So let us count in a different way. What is the different way? So let d divides n. Okay, this is the meaning of d divides n. So d is a divisor of n. Then I am looking at collect all rational number all rational numbers with denominator d. What it says, like I have written in lowest form, and then if you look at, if I cancel out also, the denominator will be a divisor of n, because I am cancelling. So whatever will be the denominator, some cancellation will happen, and then whatever remaining will be a divisor of n. So then I fix d. And look at how many rational number I get with denominator d. So that is what I have written. Collect all the rational number from this list with denominator d. So how I get what is the number? So claim is like collect and count them, and then okay. Oh, sorry. Oh. Then count. Some problem is happening. Okay, so how to count? If you look at first collect, so I am saying this is my claim. I'll prove this. If r is less than equal to d, and r, I mean between 1 and d, and r is relatively prime to d, then r by d. Any question? Okay. So r by d each in this set. In this set means that n rational number, whatever I have taken from the beginning, I am saying by reducing it to lowest form, if I am saying this is my claim, that if r is a number between 1 and d, and r is relatively prime to d, then r by d is in that set. Okay. So the claim, so now I am going to prove the claim. What is r by d? R by d, if I don't write in lowest form, so what I do, n by d r, I multiply numerator and denominator. So this I get n by d r by n. And what I have, n by d r is between this is a number which is less than equal to n. Okay, because r is between 1 to d, d into r is number which is less than n. So what it says? So it says that r by d, if I don't write in lowest term, this will be this. And since n by d r is less than equal to n, so this is in that set, because from the beginning we know that we listed the set of rational number which is 1 by n, 2 by n, 3 by n, like that, 1 by n, all up to n by n. And I am saying that n by d r is a number of positive integer which is less than equal to n, and r by d is this. So that means this number will be in that set. So that means r by d will be in that set. So that means what I have proved, I have proved that for each divisor d, means if I fix a divisor d, then r by d, if r satisfies this condition, then r by d will be an element there. But what is that number? Then second step I have written that count them. So I have collected means this set will be r for each fixed d. I am saying that r by d will be there. R by d such that 1 is less than r less than equal to d, and r is relatively prime to prime to D. Okay, this set. And if I look at how many elements are there, it will be, this is phi D in number, because R is varying from 1 to D and R is relatively prime to D. That by the definition of Euler free function, we know that this number is phi D. So this is total number is phi D. So that means what I have written here, that for each divisor D, R by D, if I collect R by D having this property, then they are in that set and the total number is of that is phi D. So for each divisor D, I get phi D number. So that means if I sum them, because if I sum them, phi D, D dividing N, I should get, because the new denominator is a divisor of N, first we saw, and then for each divisor D, I collected how many rational numbers will be there, that is phi D, and then I take the summation. For each divisor D, I take the summation, and then that will give the total number, which is N in number, 1 by N, 2 by N, up to N by N. So that is N in number. So that is why I have got this result. Okay. So this is one important thing. So in proving the other properties means we want a formula for phi of N. So next thing, okay, I have 15 minutes maybe. I'll do it within 15 minutes. So next thing so this is the thing we'll be needing to get the required result. But one more thing is what we want, we'll be using to prove this result is something called Mobius function. Mobius function. So Mobius function, what is Mobius function? So this is a function from N, again set of natural numbers, to 0, 1 and minus 1. It takes values 0, 1 and minus 1. So what is mu of N? Mu of N is, this is minus 1 power k if N is P1 Pk. So P1 P2 Pk means like N Pi's are all distinct primes. Okay, this is the definition. If so first is, so if N is a product of k distinct prime, then it will be minus 1 power k. So k, it has to be distinct, means P1, P2, Pk, because any number we know that you can write it as product of prime numbers. But I am saying that all are distinct primes appearing there, then it is minus 1 power k. K is the number of distinct prime, all distinct prime. 1 if N equal to 1. So that means mu of 1 is 1 and 0 otherwise. So this is the like formula for mu of N. Like this is the definition of mu of N. So it takes value 0, 1, and if k is even, then we get 1. If k is odd, then here in this case we'll get minus 1. So the next, which is very important and not for this purpose, it has many applications, is called Mobius inversion formula. So this again I will not give a proof, but this is very useful. This has many applications in algebra number theory. So let it says that Fg are functions, like the domain is the set of natural numbers. If Fn, so they are related, Fn and Gn are related by this d divide n. Okay, so if you look at like in this previous result, we have got formula like this: summation phi d dividing n is n. Here Fn is n and Gn is phi n. Okay, so that is why we need this. Then it says that this is called Mobius inversion formula. So here it says that F you can write in terms of G, then Mobius inversion, it says that inversion means G you can write in terms of F. So then it says that Gn is summation D dividing N mu D F N by D. Okay, so in terms of you are writing G in terms of F, but again this Mobius function comes. So that is why this Mobius inversion formula comes. So as I have explained, means like the summation means D dividing N means you are taking over all divisor, positive divisors of N. So also actually will not be using this, but this converse is also true. Is also true. I am not going to give a proof of this result. This is very, it has many applications. So converse is true means if Gn is, you can write like this, then F also you can write like this. So converse, if then means like converse means you have to consider the first statement this, and then this implies this statement Fn is this. So converse is also true. So this we assume that this is true, Mobius inversion formula. Then now I am going to get this formula that if N is P1 power R1, P2 power R2 up to Pm power Rm. So note that means like by unique factorization, we know that any integer, positive integer, you can write it as product of prime powers. Okay, so that is what I have written. So N is product of prime power. So where R1, R2, Rm are integers, positive integers, and P1, P2, Pm are distinct primed. Distinct primes. Okay, so this is the condition. Then, so if this is the case, then this says that we have a formula for phi of n. Phi of n is n into 1 minus 1 by P1, 1 minus 1 by P2, like that, 1 minus 1 by Pm. Okay, this is the formula. Okay, so now to that question, so what is phi? I'll come to this proof, but let us see whether phi of 100 is what. So 100 is what? 100 is 2 square into 5 square. By this means like I have to write in this form 2 square 5 square I have written here. Then phi of 100 is, by this formula it says that 100 into 1 by 1 by 2, 1 minus 1 by 5. If you look at what you get, this you get 40. You can calculate this. So this is what like using this formula we got phi of 100. But now let us try to prove this. Let us try to prove this result. So this previously we have proved that n is, as I have explained, all these results we are going to use here. So n is summation d dividing n phi of d. Okay, this I have proved. Here now I use Mobius inversion formula. We use Mobius inversion formula. So note that here Fn is n, Gn is phi of n. Okay. So Fn is n and Gn is phi of n. So if I use the Mobius inversion formula, so from here I get, because n is in terms of phi of n, so phi of n in terms of n. So phi of n is summation d dividing n mu d, and then Gn, Fn is n. So n by d. So that means Fn by d will be n by d. Okay. So this is independent of, I'm summation is divisor of n. So the n here is independent of d. So I can take n outside. So d dividing n mu d by d. Okay. So now let us look at I have given the formula for mu d. Note that mu d, if n is product of distinct primes, k distinct primes, I get minus 1 power k. If it is 1, then I get 1. Otherwise, it is 0. Otherwise, means if suppose in this factorization, if one prime appearing twice, means like maybe prime power, some power is more than 1, then this will give me 0. So the easy thing here is that if I want to calculate this, I have to look at d, for which d means positive integer, such that its this factorization don't have power of prime. Means like power of prime, only that prime appearing should be power 1, not more than 1. Otherwise, this is 0. So I do not need to count. In that case, if power is not 1, means like if there exists at least one prime in the factorization of d, and the power is bigger than 1, then mu of that d is 0. So then I do not have to compute. Okay. So that is why what I do here. So I what d will contribute here. I have to look at what d for which mu d is not 0. So what d means, if you look at, if n is given, let me write, n is given p1 power r1, p2 power r2 up to pm power rm. So this is there. So d for which, means just list down d for which this is not 0. Then you have to take distinct prime. So distinct prime first, anyway, you have to take d equal to 1. Okay, 1 is a divisor of n, and then mu of 1 is 1, we know. And then you take any question. So okay, so now the thing is, okay, so now 1 is like non-zero, so that will contribute. Now d can be any of 1 prime, pr, pm here, it should be pm, not pr. Okay, m in number. So pm. So pm, now you 1 prime, then you take 2 prime together. So all will be divisors of n. So p1, p2, p1, p3, like that, means like you get pm minus 1 pm. Okay. So if you collect, means at the end, if you go like this, means like you get at some point, this will be p1, p2, pm. So what I am doing here, that 1 separated to 1, then you take 1 prime, p1, p2, pm, all are will be divisor. Then you take product of 2 primes. Here I have taken all product of 2 prime I am listing. Then you take product of 3 primes, and then product of 4 prime, etc. At the end, you will get like 4 prime, 5 primes, etc. If you do, then at the end you get just product of all primes, p1, p2, pm. So this is one number. This is a divisor of n. So except for these, you do not get anything, any divisor of n which will give you mu d non-zero. Because if prime power, if you like, suppose p1 square appearing here, so p1 square p2, that will give me 0 by the definition of Mobius function. So if I use this, so what I get here, phi n is common. N is common. I'm trying to see. If I look at, if just I put d is 1 is, and then d is 1, so I get here 1. Then 1 prime, because I have written that minus 1 power k, where k is the number of distinct prime. Okay, here 1 prime, so I'll get minus here. Minus 1 power 1 is minus 1. And then if I write mu d by d, mu d is minus 1, so minus I am taking out. And then I get summation 1, just I write 1 by pi. Because for p1 I get 1 by p1, I mean minus 1 by p1, minus 1 by p2, minus everything I am taking out. I get this. So similarly, if I take 2 primes, then minus 1 power k is here 2. So I get just means like product 1 plus 1 I get, pi pj I get, And because I don't want repetition, okay, don't want repetition means if you see, if I take P1, P2, I don't want to take P2, P1 again. They are the same divisor. Okay, I don't want to count them. So that is why I have this condition that I is less than equal to j. So this condition gives me that I am not taking, I am taking one of them, P1, P2 and P2, P1, I am taking one. And similarly, so next 3 primes if I take, then minus will come. And at last, actually, if I go like this, then I'll get plus minus 1 power m 1 by P1, P2, Pm. Okay. So this is what I get. Now, what I say that whatever I have written here, I'm saying that this is what I wanted. That I'm saying that this is same as P1, like what I want to prove up to 1 minus P power m 1 by 1. How this is true? Because what you do here, what I have written n here I have written, so n is there. So only thing is that if I take 1, 1, 1, 1 multiply, this 1 is there. Then if I take, suppose I multiply with minus 1 by P1 and remaining 1, then I get minus 1 by P1. Minus 1 by P2, remaining 1, so then I get minus 1. So this sum I'll get. Next, what I do, similar thing I do, that minus 1 by P1 and minus 1 by P2, remaining 1. So that is why I am getting 1 by P1, P2 like this. So ultimately, this says that this formula, whatever written I have, is same as this. So this gives a formula for the general function. Like general n, we have a formula, and then we saw that we could easily calculate phi 10. So once you have the prime factorization, you can easily calculate. And this is a very formula. You don't have to list, etc., and then do this. This is a formula. And one more thing which I will say, I'll not give a proof because already I think I have 1 minute maybe. So proposition is that phi of mn is, this also helps you in calculating the phi n. Phi of n if m and n are relatively prime. So this says that like phi of mn is phi of m, phi of n. If m and n are co-prime or relatively prime, then this is true. So this property is called the multiplicative property. So this is called, so then we say that this phi is multiplicative. Okay, so what we have seen, let me start with this. What we have done, I have defined Euler's phi function, then I proved Euler's theorem, and then this has some applications. So applications in finding the digits instead of computing the instead of finding the full decimal representation, you can still find out the last 2 digits in this case. Like here I have just taken last 2 digits. Like last digit means instead of 100, you just need to take last 3 digits. Means instead of like 100, you just take 1000. So in that way, like you can get last 2 digit, last 3 digit, last 1 digit, etc. So we have got some application using the Euler phi function, and we saw in the application that we need to compute the Euler phi function of number, and in general for big number it might be difficult. So next our aim was to compute the Euler phi function of a general integer, positive integer. And first initial cases we saw that if p is a prime, phi p is p minus 1. And then next, not that straightforward, but what we were able to prove that phi of p power r is p power r minus p power r minus 1. And next we came to get a general formula for phi of n. For that we proved this proposition first, and then we introduced the Mobius function, and then Mobius inversion formula. We stated Mobius inversion formula, which we applied to the Euler phi function, and then we got a formula for Euler phi function in general. And then I wrote that this next proposition, which this one can easily prove by using the previous result. So this can be proved using this. Okay, using this, using this result, that phi n is this, you can easily prove this result. I am not giving a proof, and this property is called multiplicative. Multiplicative means if I have two positive integers, GCD is 1, and then f is a function, f of mn is f of m, f of n, then we say that this is a multiplicative function. So phi is a multiplicative function, we say. Okay, so hopefully, okay, so this is time is over, so I don't want to do anything else. So any questions, I'll be happy to answer.
Thank you, sir, for your informative talk. Students and other participants, anyone having any questions, please ask. You can ask by unmuting yourself, or you can type in the chat box. I will ask her. Sir, ପିଲାମାନେ क्वेश्चन ପଚାରିବା ଆଗରୁ sir ଆପଣ ଟିକେ ଗାଇଡ୍ କରିଦିଅନ୍ତୁ ତାଙ୍କୁ ନମ୍ବର ଥିଓରିର ଫ୍ୟୁଚର ମାନେ ସେ ପାସ୍ ଆଉଟ୍ ପିଲା ଅଧା ଅଛନ୍ତି ତ ସେମାନେ ରିସର୍ଚ୍ଚ ଓରିଏଣ୍ଟେଡ୍ କଣ
ମାନେ ନମ୍ବର ଥିଓରିର କିଛି ନାହିଁ, ମାନେ ସବୁ ମାନେ ନମ୍ବର ଥିଓରି ଏଟା ତ ବେସିକ ଜିନିଷ, ମାନେ ଯଦି ଫ୍ୟୁଚରରେ ଯଦି ଆଗକୁ ପଢିବାର ଅଛି କି ଯାହା ବି ଅଛି ତ ମାନେ ମ୍ୟାଥମେଟିକ୍ସ ମାନେ ଏଲଜେବ୍ରା ଆନାଲିସିସ୍ ଯୋଉଟା ବେସିକ ସବଜେକ୍ଟ ଜାଣିବା କଥା, ମାନେ ଏଇଟା ତ ନମ୍ବର ଥିଓରି ମାନେ ରେ ବି ୟୁଜ ହୁଏ ସବୁ ବେସିକ ଜିନିଷ ଯୋଉଟା ମୁଁ କହିଲି, ଏ ଯୋଉ ଗୋଟେ ଯୋଉ ଅଏଲର ଫାଇ ଫଙ୍କସନ, Euler's theorem. In the proof, I said that use group theory. So somehow using group theory. So mostly in algebra, number theory, what we do generally we use algebra and analysis, both the things, and many other subjects also we use topology, complex analysis, etc. Many things we use. So if you want to go forward, means like do some higher education in this mathematics, then you need to learn other subjects first, algebra, analysis, or whatever basic subjects that is being taught.
Okay, sir. Thank you, sir. Any question?
Sir, thank you, sir.
Sir, someone is asking.
Any question?
Sir,
Yes, Mudra, you can ask.
a to the power 5 n equal to 1 into mod of mod n. Always possible.
Always possible means?
He is asking the validity of that theorem. A to the power 5n is congruent to 1. Is it true for all a?
No. This is not true for all n. This is true if the GCD is 1. GCD of a and n is 1. Then you can write like this. For example, you take 10, and then a is 10 and n is 10. Whatever power you take, whether that will give remainder 1, 10 power 5 or whatever, that will give remainder always 0, no? 10 square you take 100, 10 cube 1000. If you divide by 10, if you are taking a is 10 and n is 10, then you cannot get congruent to 1 mod 10.
No, sir.
Sir,
Okay,
how do we prove the Euler's theorem, sir?
that is what I wrote, that use group theory. I haven't, because that will take more time, so that is why I didn't want to go into group theory.
Sir,
So
some hints, sir.
some it is general result. Actually, this what you say, that is Lagrange theorem. I think this follows from Lagrange theorem of group theory. If you have studied group theory, This is general result. Any group theory, if you study, so this as an, I think after Lagrange theorem. So if it is a finite group, that is, if it is I think from Lagrange theorem as an application or something like that you get. I think I don't remember, but if you study group theory in the first course in group theory, you prove this. Is it okay? I mean, like answer is satisfactory or not?
Yes, sir.
Okay.
Yes, sir. Yes, sir. They have studied group theory, so if they will try, they can prove it.
I think this will be like if you have studied Lagrange theorem or anything like that, then you should be able to, what it says that you are taking a group. Like it says that like you are taking a group,
Finite group,
a finite group, and then the group you are taking is that you take Z mod NZ, and then Z mod NZ, you are taking the UN, whatever that is called. That UN means you consider the relatively prime kind of thing. The same thing what we are defining for Euler phi function, and that will be a group with respect to multiplication modulo, like product modulo whatever. And then it says that if you take an element there, element power that group order,
yes,
each
sir.
one. That is what I think you do. So I think from here it should be, so like this is not complicated, but this says that like it depends on the group operation, what you define the group operation. So if you are familiar with this group operation modulo this one, like this modulo, when you do that, then it is direct, straightforward. Yeah, is it okay?
Yes, sir. Thank you, sir.
Yeah, any?
So to prove phi of mn is equal to phi of m into phi of n, do we need Mobius inversion formula?
No, that is what I said, no? That if you, to use this, like, do you need means what? You are to prove this formula, this proposition, to prove this proposition, you are needing Mobius inversion formula.
Not
And,
this one. So the multiplicative property.
And that is what
Last
I am
one.
saying. Multiplicative property, you are using this result, this proposition. So indirectly, you are using Mobius inversion formula. But I am not saying that this is the only proof. You can also prove without using Mobius inversion formula also.
Okay, sir.
But I am saying that indirectly, you are using Mobius inversion formula. Since I said that this proposition, to prove this proposition, you need this proposition. And this to prove this proposition, you are using Mobius inversion formula.
Yeah.
Sir, sir, there is a question from YouTube.
Okay.
Sir, they are asking, is there any geometrical interpretation of phi function?
Phi function, I don't know. I don't know any geometrical interpretation. I don't have any idea.
Okay. So, sir, we'll end the talk. Sir, I request Dr. Kaur, sir, to give the vote of thanks. Sir, please.
Thank you, sir.
Thank you.
Professor Javan Kumar Meher, for your nice presentation, and you explained the topic so liquidated manner so that our student will understand it easily, and the students and all the participants, they enjoy this topic very much. Although it is difficult, but you explain in such a way, so everybody is interested to listen the whole time, and the students from all over our district, they participated and they are benefited, I think so. I thank our principal, Ravindra Kumar Devta, to help us to arrange this type of webinar. And I also thanks HOD Mathematics Nursing Panigrai and his teammate, Dr. Mita Sharma and Pragya Parimita Patel, to arrange this webinar in a nice manner. I thanks our technical team and all the staff members for their participation. Thank you everyone, and we hope, sir, for your this type of help for us in future. And
Yeah, definitely.
you enjoy, sir. Enjoy.
Yeah.
If you have time, if COVID is out, then you may visit our college. So will be very much helpful. Our student will be benefited, sir. Thank you, sir. Thank you very much. And
Thank you, Kumar sir. So the talk is come to an end now.
No, anybody can ask other type of question, not related to talk. Anything like what to do or something like that, or
Yes, sir.
students are free. Students are free to ask now because once talk is over.
sir, one thing, sir, I want a question. So now it is very students are very much interested about computational mathematics. So you give an idea that how students of this graduation student they can enter into this field, computational mathematics.
Computational mathematics actually, yes, means like now many things are the data analysis, many things mean like computer related people are very interested.
Yes.
That is there. How means like
So this general students, this pass out BSc pass out student can enter to this field.
BSc student mean like for them I think it needs to be mean like they have to do MSc at least.
After graduation, I hope they can enter this field to get a job easily in computer field.
Computer, I do not know much about that. I do not know much about that. Mean like directly, mean like what actually mean like maybe one computer scientist or computer science faculty may be better person to give idea about, because that is related to computer science. I know very little about that. I use sometimes, but I do not work on that.
Okay, sir. Thank you, sir.
Yeah, no student have any question?
So what are the areas of research in number theory?
Research in like there are many areas. Like what I gave today is basic things actually. So if I want to explain now, you will not be able to understand actually, because the thing is that number theory, what happens, number theory is easy to state some result, but it is difficult to prove. Okay, like many things you have to use, as I said also before, that you have to use tools from many other areas like algebra, analysis, topology, etc. Topology possibly you haven't seen, but the MSc generally they study. So all these things you use. And what are the areas? There are a lot of, like there are many branches of number theory: analytic number theory, algebraic number theory, modular form, L functions, like many things actually. Many things are there, and then like anything you do actually. It is not that like people say that research one cannot do anything. You start, you will be able to find out this area, and then many things will be there. But for that to do, actually, you need to have that training in the sense that at least to tackle those kind of problem, you need some like other areas idea also. Other areas also you need to study. Not just like number theory. If you want to do research in number theory, you have to do like you have to learn other areas also.
Okay, sir.
सर नंबर थ्योरी आउ क्रिप्टोग्राफी रो जो अछि सेटा दिए कहि देबे जदि पिला माने नंबर थ्योरी को आउडी इंपोर्टेंस देके पढिए।
हाँ नंबर थ्योरी बहुत माने से हिसाब एप्लिकेशन देखले माने नंबर थ्योरी क्रिप्टोग्राफी किंबा कोडिंग थ्योरी ये सब माने जहाँ भी हेले भी माने जेते भी जहाँ कहली से समान जिनिस माने नंबर थ्योरी क्रिप्टोग्राफी एप्लिकेशन अच्छे लोग माने करूछन सेटा इटा किंतु से माने भी बहुत जिनिस अलगा थ्रू भी यूज होची तो से लगी मुझे कहनी कि जिनटा कले भी माने डायरेक्ट नंबर थ्योरी तो जहाँ हेले गोटे पार्ट है माने से क्रिप्टोग्राफी रो नंबर थ्योरी गोटे पार्ट है किंतु जिन एरिया रे रिसर्च होची जिन एरिया रे रिसर्च होची माने से माने बहुत जिनिस माने यूज करूछ जदि जने रिसर्च रे आसबा ले चाहबा बेले
सर एनालिसिस बहुत पिला को बोर लागते सर तो टिके मोटिवेट कर दो एनालिसिस अलजेब्रा ऊपर कहीं सेडा सर हमर मैथ रो बेस है विदाउट डूइंग दैट माने किछि करि ना पारन फ्यूचर रे सर।
हाँ एनालिसिस अलजेब्रा तो मेन जिनिस माने बाकी सब जहाँ भी अच्छे सब एनालिसिस आ अलजेब्रा रो ही माने मैक्सिमम जिनिस माने प्रूव हेसी आउ एनालिसिस माने केन बही माने पढुजन
सर ईमान को एनालिसिस रो तो सर
दास पटनायक
सर हो सेडा भी पढुछन सर आउ सीबीसीएस रो सर जेन बुक प्रिंट करिना कल्याणी पब्लिशर होचे बहुत सा सेडा के फॉलो करती।
हाँ 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 ना एक्चुअली काना है कि एनालिसिस रो भी माने हमें भी पढ़ला बेले भी इटा लागुतला एटा नुआ कथा नुहे किंतु एनालिसिस करबार लागि हेले पहला कथा प्रॉब्लम सॉल्व करी जानले तार पर मजा लाग आउ प्रॉब्लम सॉल्व केनते हेबा प्रॉब्लम सॉल्व माने हे जिनिस कि जणे जदी पहरा सिखबार लागि चाहबा बेले बाहर जेते लेक्चर देले भी तो माने पानी के तो जाहले भी जीवार ले पड़वा जणे जणे जदी जदी पहरा सिखबार ले चाहबा तो ताके पानी भीतर के पसवा ले पड़वा जाहले भी तो बिना पानी रे जाई करी जेते जणे कहला ना एंती कॉलेज हेबा एंती कॉलेज हेबा एंती पहरा तो ना सिखि भाई केनसी भी हिसाब तो हेति लगी तो माने एंता भी हेसी कि गुटे गुटे प्रॉब्लम नै होय माने 2 दिन 5 दिन केनसी भी नै होय बड़ बरस भी नै होय से टाइम रे माने हेंता भी हेसी हेंता भी होई जे मोर भी हेंता हेई जे तो हेंता हेसी सेतिरे नुआ कथा नहे किंतु केनसी भी जिनिस मैथ रो खाली थ्योरी करले नै होय माने तार प्रॉब्लम करबाटा निहाती दरकार प्रॉब्लम करी करी माने माने पिला माने निजे भी डिस्कस करले भी निजर निजर भितरे किंबा केबे केबे टीचर मान को ओइटा करी करी भी करी पारबे माने कम से थिरे इंटरेस्ट आसबा जदी प्रॉब्लम जणे करो आ खाली थ्योरी हेले काणे हबा कि खाली थ्योरी हेले से माने का थि लागि पढ़बे खाली जे करी एग्जाम रे पास करबार लागि कि एटा माने घुसी करी तार पर जे करी सेनो माने लिखि देले पास हो जिवे कि जहा भी हैला तो हेंता हेसी माने हमें भी हेंती करथिलु किंतु परे इटा इटा जानलो कि हेंताटा ठीक नुहे माने हेतिरे माने सिखि ना होय किछि आ मजा भी ना लागे
सर किसी भल बुक एनालिसिस रो गोटे दिटा सजेस्ट करबे
एनालिसिस हेटा तो भल बही है किंतु हेन प्रॉब्लम सॉल्व करबार ले पड़बा जेन माने दास पटनायक रो माने डिफिकल्ट लागसी माने स्टार्टिंग रो माने बीएससी रे डिफिकल्ट लागसी किंतु मुई मते डिफिकल्ट लागतला आ से टाइम रे माने एमएससी रे मुई हे बही तार परे इटा करूतिली एमएससी रे माने एमएससी रे आमे मुई धरी करी बही जाउतनी आ से टाइम रे ये थिले माने आईएम रे डायरेक्टर थिले स्वाधीन पटनायक डायरेक्टर थिले से टाइम रे तो से टाइम रे मुई जे करी ताकर नि के जाउतली माने क्लास सरी गले आईएमए यूनिट 9 रे थिला से टाइम रे तो से टाइम रे मुई जे करी से टाइम रे सॉल्व करथिली माने हम बीएससी रे आमे नै होई पारी तो प्रॉब्लम हला कि जदी टीचर माने चाहेबे भी करी हवा माने किछि किछि प्रॉब्लम आ सेटा हेते बेसी डिफिकल्ट भी नहीं माने टीचर मते लागसे कि टीचर माने मोटिवेट करबार कथा आ किछि प्रॉब्लम सब प्रॉब्लम ना हेले भी माने ता जेन एक्सरसाइज रे अच्छे किछि किछि प्रॉब्लम तो करी हवा कि प्रॉब्लम डिफिकल्ट लागसी के कि केंदा
Sir, students को तो आगे real analysis कहीं तो नहीं है।
हाँ नहीं हेटा है माने रियल एनालिसिस ता तो ई जिनिस है माने सेटा तो ठीक एल्जेब्रा तो कम से कम टिके याडू साडू टिके बेटर लागसी हेले भी केबे केबे किंतु रियल एनालिसिस एप्सिलॉन डेल्टा ई सब आसला परे टिके इटा हेसन
मैंने प्लस 2 लेवल में डायरेक्ट बीएससी रे तांको थियोरिटिकल हे गले
हाँ
मैंने डिफिकल्ट है
हाँ
सर आज बहुत मोटिवेट तो हेजन पिला माने फ्यूचर रे सर थैंक यू सर
ठीक है